Statisticians, welcome back for another riveting installment of your journey in AP statistics. We're going to pick up with the back end of our first lesson in Unit 2 on transforming data. Last lesson, we learned to interpret the standardized score or the z-score of an individual value within a distribution of data so that in this lesson, we can describe the effect of adding, subtracting, multiplying by, or dividing by a constant on the shape, center, and variability of a distribution of data. Without any further ado, let's get into it. So as we can see here, we have two images that have some subtle differences between the two of them. I wouldn't say that they are, easy to spot, no pun intended. But these images capture what is a growing trend, not only in the United States, but other more developed countries. And that trend is wealth inequality. These two homes are located approximately 1 mile apart in a community in Texas, but as you can see, they are vastly different in their grandeur, in their aesthetic, and most likely, and obviously I'm, offering my 2 cents here, in price. So we're going to utilize some data in this lesson that's going to allow us to accurately, or more accurately, I should say, answer whether or not wealth inequality is increasing or decreasing. So back in 2019, the Texas House and Senate passed a school finance bill to provide teachers with raises. In the first proposition, they had decided that everyone at El Paso High School was going to receive a $6,000 raise. So on the left-hand side here, these were the original salaries of 12 teachers and school faculty, right? 29,000, 32,000, 34,000, so on and so forth, up to our anomaly of 185,000. Let's say that this was the principal. And then after the $6,000 raise, this is what the data set now reflects. I would like for you to take 30 seconds here, pause this video, and predict what will happen. Will the mean increase by $6,000 or will the mean remain the same between the two data sets? Will the range increase by $6,000 or will the range remain the same between the two data sets? And will the shape of the distribution change or will the shape remain ultimately the same? In this screen here, we have our original data set here and our dot plot values graphed accordingly, frequency on the left-hand side. And we have our original descriptive statistics, standard deviation, interquartile range, median, mean, and mode. By pressing play, we are going to alter, and it'll happen in black, right, the value of the teacher salary. So when we get to 6, we have hit our $6,000 range. So you should have noticed that some values were changing while some values were not changing. Based on what you've noticed, visually speaking here, we can see what is happening to the two distributions. So let's assume that we had a normally distributed set of data with a mean of 10. If we were to increase every value by 6, the mean would then shift to the right-hand side or to the right, subsequently increasing the value of the mean to 16, and vice versa had we decided to subtract 6. So the effect on our measures of center is they are going to add or subtract by the constant amount. And fear not, I will ensure that that is turned to text so you can type. As far as the spread, we can see that the variability here has not been affected. And if we play our slider once more, the two measures of variability, standard deviation, IQR, did not change because we are not changing the distance between each of those individual data values, nor the first and last data value. So the spread is going to remain same, as is the shape. So just to conclude, once again, if we are adding or subtracting every data value by a constant, the measures of center, so your mean, your median, let's go back one, and your mode, will add or subtract by the constant value, while the spread and the shape are going to remain the same. You know, legislators at this point and policymakers can never agree seemingly on anything. So a subset within the House said, hey, $6,000 to everybody, that's not necessarily the best way to do things. Let's instead give everyone a 10% raise. If you're not familiar with percentages, when we apply a percentage growth or percentage decrease to a particular data value, we do that utilizing multiplication. So in this regard, we're going to be multiplying each of these data values here on the left-hand side by 1.10, the 0.10 representing 10%. Now I'd like for you once more to pause this video and take 30 seconds to decide how you think the measures of center, measures of spread, and shape will ultimately be affected. We have our same set of data once more, and we are going to apply a 10% raise. Oops, little typo there. And as you can see, there we are, right? All of our descriptive statistics were changing. The range is changing because the multiplication of 1.1 is going to affect, obviously, the larger values like this outlier here, more so than the smaller values, as well as our standard deviation and interquartile range, because our mean, our median, and our mode are going to change as well. You should select this image here because I cannot, but so it can blow up. But as you can see, if we have an original data set with a mean of 4 and a standard deviation of 2, and we multiply that data by 2, the mean is going to double and become 8, as is the case with the standard deviation. Subsequently, if we decide to reverse that process and divide by 2 and or multiply by 1/2, the same trend will follow suit. So this should not say adding or subtracting. That should say multiplying or dividing. My apologies. Decent amount of typos in this video. That's all right. I'll make sure that they're all modified. Need to change this as well. So the effect deal with that. Multiplies or divides by the constant amount for the center. The same holds true for the spread. And as for the shape, it remains approximately same. Arrow may broaden or steepen depending on operation. So how does this really apply to wealth inequality? As you can see here, we have two time graphs that chart the U.S. real family wealth over time. Orange is represented by the bottom 90% of the economy, and the gray below represents the top 10%. Make sure you take a good hard look at your vertical axes, which detail the average real wealth per family in dollars. The bottom horizontal axis of the graph represents time. I'd like for you to just generate some discourse here with your peers. What are some things that you notice regarding U.S. real family wealth over time? What are some things that you wonder regarding U.S. real family wealth over time? And in this final piece, we stack them together on the same graph and reorient our vertical axis. Wealth here we're defining as all assets, stocks, home value, bonds, etc., etc. Why do you think that wealth inequality is increasing? And then to conclude, is wealth inequality a problem? If so, what should we do about it? And if not, why not? As always, don't forget to reflect and synthesize by completing our two reflection questions and then providing me with any information regarding some misconceptions and hesitancies you might be having. I will see you in class.